Hello there, I'm Genevieve LaLonde, and I'm presenting my final project from the Internet Web and Cloud class in fall of 2022. This is a web application that is hosted on Cloud Run, and I call it, Do We Need Bananas? So without further ado, let's go straight to the demo. Now, what is the first thing that you need in order to have a web app? How about some code? This is hosted on GitLab along with the rest of my course information. So let's cd straight into that and into the final project directory. So you can see my code here. Now I do have a README here, so you can see some basic information about how you would deploy locally with gUnicorn. You'd need to set up your environment, but we're going to be hosting it on Google Cloud in a container, so we're not going to do that. Instead, let's go ahead and build it. Now, if you were just going to build it in Docker, you could build it locally like this, but we're not even going to do that. We're going to build it on Google so that we don't use our local resources. Now, you'll notice in this command, I have set the environment variable. I've actually set several environment variables, including the permissions I need for my APIs. So make sure that you always do that before getting started here. I'll go ahead and pause my video while the rest of this builds to save some time in the presentation here. All right, welcome back. I hope you enjoyed your tea break. So the build has finished, as you can see here in my command line, and we can also go ahead and check on that build. If we type it correctly, we can. And you'll notice it's displayed up here at the top. This is my third iteration. Got to perfect that video, and you can also see it down below. So what this has done is used Google resources to go ahead and build that image instead of building it locally, but it's not yet deployed. So let's go ahead and deploy it. Now you'll notice in this command, it is using a service account. So be sure that you have set that up ahead of time. For example, this service account, I just call it Banana App. And I've added the permissions that it needs in order to run this application. Having that ahead of time ensures that it can build smoothly. I've also configured environment variables, which are being pulled in as environment variables from my shell into this command, which are then being used as environment variables and populated into the container itself. And you'll see that was actually a very nice, fast deployment. It's finished and it has given us the link down here. So let's go and check out our app. Okay, so this is my application. Do we need bananas? So the motivation for this app is anytime that you're living with other people, oftentimes you'll share grocery duties. And there's a lot of different modalities where you could be tracking this in a notepad or in a whiteboard, or maybe even a shared note on your phone. But in each case, you're constantly having to type things in and then delete them again. And it's just a lot of effort. Maybe you can't take that whiteboard with you, so you have to write it down on a sheet of paper. And then invariably, I'm always at the store and I'm wondering, do we need bananas? And I have to message someone at home. And so this way, you can just ask them to upload anything onto the app that you need instead of having to coordinate like that. So how can you use it? Well, let's go ahead and add. I do want to talk about the style for a minute. I'm not a front-end engineer, but I really like a dark teal color like this. So I themed my app that way and added a little bit of CS like for these hover buttons. So let's go check out. And I do want to point out another CSS thing is I've added the icon here and a title for every single page. So if we cancel this and go back, you can see we've still got the bananas icon and we've got a different name for this page and here for this one. So I'm so proud of that little touch there. Okay, so we've got a list. We need some products on it. What should we add? How about some bananas? And what this is doing is it calls the Kroger API and it pulls this information about that product. So we've got the image, we've got a description, the category it's going to be in the produce, and its location in the store. But downside of this is I still have to type everything out, and that's what I was trying to avoid. So we could pull things up from a Google bucket instead. Oh, and it's right here. So here I have my Google bucket, and I've just taken a picture of my whiteboard, and I'm going to use the Google Cloud Vision API to recognize this handwriting and populate that into my list. Oops. Did not properly copy. All right. So what this does is it pulls, it processes over each one of those words, and then it calls the Kroger API on each one of those items, so we can see them added here. Now, one thing you might notice is we have bananas bread. That is because indeed, when I wrote them down, I put them practically on the same line. So Cloud Vision interpreted them that way. In fact, with a bit of a typo because of my handwriting. And that's actually okay because the Kroger API does a fuzzy search. And so it's able to match things like that to banana bread. Now, if that's not exactly what you were looking for, though, you can go in and delete it. Oh, right, we'll notice that is gone now. You'll notice that I deleted it by product name. And the reason that that is successful is because that is the key in my data store. I chose that because it's not a lot of times that you want 2 bunches of bananas when you go to the store. Oftentimes you might forget that you've already put it on the list, and so you add it again, but you really only want 1 entry. So I've set it up so that if another entry comes in, it's just gonna write back over that again. And you can see that here. If I go in and add again from the same exact image, then it's going to create the same things. And it did recreate that bananas bread. So let's delete that again. I will also point out, I don't know if you noticed, but it was a little bit faster pulling that image the second time. And that's because I check whether it's in my database before calling the Kroger API, because that API is a little bit slow. And now that we have entities in our database, we can see them here in data store. There's our apples, bananas, and our chicken broth. And you can see their IDs as well. Again, I didn't set the key on the ID, but rather on the name, as you can see, because it's blue. All right, that is our functionality for our app. And also delete can be used not just for removing mistakes, but also for deleting the items when you're in the store. So let's go and take a look at the code that makes all of this work. Here's our code. So the main thing that you're going to hit is going to be the app.py. This is actually how you call your app, and we specify our routes in there. One for the index, for adding groceries, and for deleting them. And then, of course, they're going to be run by Flask. Now, for each of these different routes, we're going to have 2 files. Let's take a look at the index. We've got a Python file, and in the templates, we have an HTML file. Now, another thing that's incorporated into each of these pages is the layout. And this sets kind of a standard view for each of the pages. You can see the icon, the head and body, all of that gets set in here. And then this is populated by the individual pages. For example, back in our index, you can see that we are starting that block content, but we have our own title, we have our own content in the page, and then down here, we actually have the rest of the body. So the cool thing about Flask is it allows us to do some scripting, even in our HTML. We've got this for loop, we can pull in some variables, and we've got those images up there. And down here, we're even using that in the buttons. This is the button to add to the list and delete from the list. You can see those go to add groceries and delete groceries at the end of our block. And then the equivalent in Python, not much on the code on this side, just making sure that we can talk to our model, select it so that we can show all of the entries and processing those entries. We've got really similar things going on in add groceries and delete groceries. Let's take a look at delete first because it's a little bit more simple. So same sort of HTML. We've got our own title. We've got our blocks, just a couple of forms with buttons so we can say what we're deleting. And then in delete, we're going to go ahead and call that model and send it a delete and which product to take care of. So let's take a look at our model. And you notice we actually have a few components in here. We have an initialization of our model, and we've got a standard format here that you can use to support multiple types of models. But I decided to stick just to data store. And so here is the actual implementation. You've got your model class with its initialization. This is where we set up the client with our project and our kind of entry, our groceries. Actually, I've got this set in here because whenever your Python app is shut down, it forgets what ID number it was on. And so I go take a look at how many entries we have and just increase the ID number 1 on top of that. And then we get a select request from our index, and that's what runs, what pulls the groceries. And then you'll notice we've got a formatter function that is up here, and it just takes that entity object and puts it into a list of lists that's more manageable. I also have a filtered select that I'll talk about a little bit later, but that allows you to just pull a piece of the data that you need so that it's a little bit more performant. We've also got an insert statement. Here's where we're actually adding those products, just updating them, and a delete statement on our model. We're calling a delete on that product itself. And I had a stretch goal to add update, but I did not implement that yet. So that'll be for tomorrow. All right, and then let's take a look at our larger page. We're actually adding those groceries. So the HTML is pretty simple itself, but the code is a bit longer here. So we've got a post statement here, which has a couple of functions in itself, little helper functions, but let's go on down here where we start processing. So we've got 2 options. We can either pull, we want to just add a single product, or we want to pull all the products from a bucket. So in an individual product, what we do is we pull that from the form, we check and see if it's already in the database. That's this helper function. And then if not, we'll go ahead and run the API. I call it get many product because it supports both. And then we'll send it to the data store once we have the data. Same thing happens with a bucket. We just do it a few more times. So we process that file name. We get our Google Vision API set up. And then down here, we do a little processing in case there's like little ticks on the whiteboard. Sometimes those get interpreted as L's or 1s. So we want to make sure that the length is at least 1. And here I call the product bananas because of course you're always going to the store to get bananas. And then down here, we're iterating through those groceries. Sometimes I put a title on my whiteboard, so we don't want to be adding that to our list. We check if it's in the database, we pull our Kroger API, and we send it to our data store. So the same thing. So let's go see what those APIs look like. So I've got 2 APIs in here. First one I worked on was Kroger, and I actually added argparse and such so I could work with it on the command line when I was trying to figure out the structure of the object. As you can assume, Kroger has a lot of products, so it's good to be able to iterate through them and filter them out. But you can see here's where we get the bearer token that's needed to interact with their API. We pull the location. I've hard coded the zip code and radius, but that's a stretch goal. I've added all the structure to be able to ask the user to specify that so that they can choose which store that they want to be interacting with. I just haven't added it into the web app itself yet, the visual part of it. So once you have chosen, gotten a list of locations, you can choose it. And here I'm just hard coding that I pull the first one. And once you have the location, you can ask it for its product information, for example, where that store stores this product. And again, I've hard-coded just a default that we're just going to pull the information for the very first object. A stretch goal would be that it'll pull the top 5, and then the user can select which type of apples they want, which brand. Those are also filters that could be added. So I've added structure for that, but not yet implemented it. So that's the Kroger API. Let's take a look at Cloud Vision. There's 2 different ways you can do it, local or from a storage bucket. And they have really good quick start guides. So it was much easier to get going than it was with the Kroger one. But I did end up just commenting out most of that and just picking out the one piece that I needed and returning it. Okay, so that is an overview of our code. And let's take a look at our Git history. So here we are in my GitLab, and let's go to the final and our history. So you can see here the types of things that I was doing. I created some files. I wanted to just get used to those APIs. So I created the Kroger.api and the Cloud Vision API, and then I implemented those into the project itself. Did a bunch of cleanups, changed some things about the theme. I did a little bit of work in a branch here, but then I realized it wouldn't show up in the history. So then I switched back, implemented the other API, did a little bit of fixing some issues with the way that Cloud Vision was formatting paragraphs or separate columns. Renamed the routes because this originally came from our homework number 4 application. So I wanted to make sure it was all customized to the new one. And then just cleaning up and getting deployed. So I hope you have enjoyed getting to learn about this application, and I hope that it would be useful for improving your shopping experience. Have a great day.